Hi, everyone, and welcome to the KnowledgeLake webinar. Thank you for joining us. We're so excited to have Brad Porter, CTO for KnowledgeLake, with us today. Brad brings a wealth of experience in driving innovation through AI and automation, helping businesses transform how they manage their data and processes. Today, he's going to share some valuable insights on how KnowledgeLake's AI-driven natural language hints are revolutionizing data accuracy and efficiency. We also have Konstantin Echt, who will demo more specific prompt engineering techniques on the KnowledgeLake platform. But before we begin, a few housekeeping items. This webinar will be recorded and available for viewing on demand. And we encourage your participation, so please feel free to ask questions in the chat window and we'll address them during the Q&A session. And now I'll pass it over to Brad.
Thanks, Pam. Let me get the slides loaded up here and we'll get going. Okay, so today we're going to talk about power of AI hints and prompt engineering. So let's take a look at the agenda. I want to spend a few minutes to start kind of setting the stage for why we're talking about generative AI, large language models, and prompt engineering. Then we're going to talk about how you can maximize your full potential with prompt engineering via large language models, some key techniques. I'm going to specifically shape the conversation around how you can use ChatGPT and KnowledgeLake, but all these techniques are going to be applicable across any usage of any AI tool in the future. We'll go through a few examples we've used internally at KnowledgeLake, and then Konstantin's going to show a demo of some of those use cases being applied inside of our product. Then we'll save time for a Q&A, and we'll try to get out of here at the top of the hour. Okay, so just a quick primer. You've heard us throw the term around intuitive AI. That's how we like to position the kind of the cross section of generative AI or large language models, prompt engineering, and work process automation. So bringing all those things together. We had a webinar a few weeks ago where we talked about agentic workflows, but you can think of that all being brought together through this one concept of intuitive AI. Just a few highlights before we really dive into the technical stuff. ChatGPT was one of the first products to get to 100 million users at the speed that it did. And it speaks to its ubiquitousness and its approachability by everybody in technology. A recent poll from OpenAI said that 61% of information workers are using generative AI for content creation, coding, or data analysis. So already seeing a lot of penetration in the market. Market will reach 110 billion by 2024. And what you're gonna hear today is that prompt engineering is a pretty new term. Really is crucial to maximizing your ROI and the value you get out of your large language models and generative AI. So let's dive in and talk about some more of the specifics. So I want to take a step back for just a minute and talk about what makes generative AI special, what makes large language models special, and why is it different from prior iterations of machine learning and AI. So the first key hallmark is that it's a unified solution for diverse tasks. If you remember over the last 10 years, when you heard about ML, machine learning, and AI, it was usually a one-trick pony. So you would train a specific model, neural network, whatever, for a specific problem. So you may have heard about Google training AlphaGo, the world's best. Go is a board game. It's the world's best board game AlphaGo player. It can beat the best players in the world, but it couldn't extract relevant facts off of an invoice or classify an image or do something else, right? So before we had transformer architecture and generative AI, you had these very kind of single purpose use case techniques. And with large language models, it's really a broad, diverse solution for many, many problems. So one model can handle hundreds or thousands of use cases, which is very, very different than the prior generation of machine learning. Second is contextual mastery. So if any of you used any of the early chatbots that maybe companies put on their websites, like, hey, I want to come to your website and maybe ask for some help or get some support. A few sentences here, a few sentences there, you could interact with those chatbots. However, if you got really deep down a rabbit hole or you put a lot of text in those chat windows, the system would get confused and have to route you immediately to a human for assistance. And with generative AI and with transformer architecture, the context windows have continued to grow. And you could think of context window as the memory that the AI has about the current conversation. And today we're actually, Google's Gemini has a 2 million token context window. So for reference, that's about a 1,500 page book. So you can imagine how much memory you can hold at one given time and be able to understand the subtleties and the nuance of your conversation. And so that's a big leap forward from the prior generation of NLP models. I think most importantly, and this kind of gets glossed over a little bit, is this idea of natural language interaction. When you think about generative AI, the reason why ChatGPT went from 0 to 100 million users over a weekend was because it was approachable by everybody, right? It used to be you had to be a data scientist, you had to have all the tools, you had to understand how to do hyperparameter tuning, you really had to get into the data. And large language models like ChatGPT make it accessible to everyone. You can use your natural language, whatever language you speak or write, it knows how to understand that and can interact with you. And so when you think about technology, since the beginning of kind of the information age, we started off, doing embedded systems, writing machine code, bytecode, moving to, C++ and C, and then to managed languages like Java and C#, eventually to web stack. And now we just keep having these rising layers of abstraction where now we just interact with the AI using natural language, and that's the way that it should be. And that's what makes it so approachable for everybody. And so we're gonna really dive in on that natural language part throughout this presentation. Another thing, talking about democratizing AI and that natural language is, if you wanted to create train your own model before, again, data scientists, lots of data, lots of fine tuning. Today, these large language models make that very, very easy. In fact, fine tuning is simply just creating a document, like a text file that has prompt response pairs of here's the prompt, here's the response I would expect. And you can use that to coach your AI, your LLM, to give the answer that you want based on your domain specific use case or data. We'll talk more about that in a little bit. And then finally, when generative AI and transformer architecture first came out, it was text in, text out, which is super powerful and a great technique. But as we've moved through the most recent wave of models, we now have what's called multimodality. So it's not just text in, it's text out. It can be image in, text out, or video in, text out, or it can be text in, image out, text in, video out. So as we increase these modalities, it allows for these AI models, these large language models, to have a better understanding and interaction with the world, which just produces better, higher quality results. So that's why generative AI and large language models are a big deal. Now let's talk about how to maximize what we get out of these. So I love talking to people about generative AI and large language models, and I'll often pose the question, how are you using it? Are you finding value in your day-to-day job? And I usually get one of three answers. There's the people that are like, I've used it. It spit out a bunch of hallucinations. I didn't really feel like I got a ton of value out of it. You get other people that are they're in love with it. They're crazy about it and they're getting immense value. And you get a few people in the middle like, for a few very specific use cases, I see value, but I don't really feel like I'm maximizing the potential. These people are all using the same underlying large language models under the hood, right? But they're getting wildly different results. And that almost entirely comes down to prompt engineering. So what do we say when we say prompt engineering? It's really the confluence of art and a little bit of science to design your inputs to guide the AI model towards your desired output, right? This technology is snowball, it's a snowball rolling down a hill. And so it's moving very, very, very quickly. And so there aren't a lot of standards on how you prompt an AI. But at KnowledgeLake, we've been working with this technology for the last 3 years, and we've mined some nuggets of wisdom that we're going to share today. But bringing that together and having great prompt engineering will be the difference between it's just okay to wow, that really delivered some value for me and for my organization. So again, why does it matter? This really enhances the accuracy and the relevance of the AI responses, and it bridges the gap between your intent and the AI really understanding what you're trying to get it to do. So some of the core competencies, and I'll say as models get more sophisticated, clarity and specificity probably becomes less important as their contextual mastery increases. But if for any of you that used like 3.5 Turbo or the early days of ChatGPT, if you asked a question, or let's say you made a compound question where you had 3 or 4 questions in a single prompt, that's a recipe for disaster, especially with the early models, to get it off the rails. So first and foremost is clarity and specificity. Be very clear in what you're asking for. Don't overcomplicate your prompt. Be very straight and to the point. Also, providing that relevant context. So you can give a paragraph of like, here's kind of the situation. Don't ask any questions in there. Just provide context. Ask your question. Get your response. those are the common, most core approaches to getting value from your large language model. And then finally, on the kind of the effective prompt engineering core components, don't think about your first prompt as being, don't think that it's just going to be a single shot. I'm going to ask a question and get an answer and that's it. In the same way, if you and I were sitting in a room on a whiteboard, kicking an idea around and ideating and brainstorming, there would be a dialogue. We'd be working together to suss out the solution to a problem. And you should think of your co-pilots, your large language models, your AI assistants as that sounding board. So you think of this as iterative refinement. You don't necessarily need to get the answer on the first prompt. Obviously, if you can, that's great. But oftentimes you're talking about something more complex and you may need to have that iterative refinement with the AI to get the answer you're looking for. Okay, so you've heard me say generative AI, and I think that's a little bit of a misnomer. I think people think of large language models and immediately assume it's only for generating content. And that's not the case. There's actually 3 main classes of use cases for large language models. And I want to just highlight some of the differences. So we'll talk about generative third. The first is reductive operations. So first and foremost, summarization. I can tell you I get really long emails from coworkers and from other people. I'm in a hurry. I need to synthesize down what they're saying and get the TLDR, right? And so pasting in or putting in, a large amount of text and asking it to summarize it, amazing at that. And they can do it for all sorts of use cases. But for me, when I get a big long email, that helps me kind of separate the key points from just the fluff. Second, and similar in vein, is distillation. So extracting underlying principles or facts by removing noise. Imagine if I fed in a chapter from a physics textbook and said, hey, I need you to distill this down into the salient points, maybe give me the Cliff's Notes, so to speak. I want to understand the core concepts, but take out all the noise. Give me just the signal from this chapter. Extraction, which is one of the key areas where KnowledgeLake uses large language models under the hood in our product, which is to retrieve specific pieces of data or facts from large data sets. For us, that's unstructured documents and content, but it's really, really good at doing that. Characterization, describe the content or the context or nature of text. Analyzing, I use this all the time where I'll work in spreadsheets and I'll work with ChatGPT or other LLMs to analyze my data and help me identify patterns, outliers, anomalies, right? It's really, really good at pattern detection and analyzing data. ChatGPT get a bad rap, I think, when it first came out for students, right? Lots of school districts around the country banned the use of ChatGPT like the week after it dropped. And I actually just finished reading a book, Strange New Words, by Saul Khan, the founder of Khan Academy. And he spends a lot of time talking about education and how he believes generative AI is going to completely overhaul the way that students learn. And so I'll give an example here for evaluation. My daughter was working on a book report the other day. And of course, I don't let her use generative AI to write the book report, but I find it immensely valuable to use it for grading. So you take your book report, you create a great prompt to say, hey, you are your job is to you're a teacher, you're evaluating a student's book report, provide feedback, provide a letter grade. And my daughter uses that to improve and fortify that book report. And it was amazing. So evaluation, it's great at that. And critiquing, providing feedback, context, another great use for reductive operations. As a software engineer, it's also great at transformation operations, right? So if I'm working with an old web service and I want to port it to a REST API, I might need to ask it to convert XML to JSON. It is great at transforming from one format to another. Or maybe I have a book and I want to turn it into a screenplay. I could do that to change it from book format to screenplay. It's great at helping me refactor code, right? If I've got a big, long 1,000-line method and I go, man, this is just not object-oriented, it's not well factored, help me refactor this to follow my best practices. It's great at that. Transforming between different languages, whether that's spoken language like Spanish to English or from C# to Java, it's great at transforming. Restructuring, modification. I'm guilty of writing an email and going, there's maybe a little bit too much negative emotion in this. Help me rewrite this into more diplomatic mode. It's great at modification. It's great at clarification as well. And so then if we take a look at the generative operations, which is what I think is normally top of mind for most people, initial drafts, helping me write a document, a blog post, a story, helps with planning to plan out my business plan or go-to-market plan or release planning or project plan. Great at brainstorming. It's really good at being your creative partner to help you figure out what you want to do. Or amplification, expanding on an existing idea, adding in more meat to a story or to an idea. So anyway, those in my mind are the top 3 categories of uses for large language models. It's not just generative. And so now let's take a look at some of the key techniques in prompt engineering so that you can make those 3 use cases really work for you. I'll just repeat this. I'm going to go at this through the lens of how you would do this in ChatGPT. However, all of these techniques are applicable across the tech stacks that you're using, whether you're doing this inside of KnowledgeLake, whether you're using Gemini from Google or Claude from Anthropic or ChatGPT from OpenAI. All these techniques are the same, but I'm going to focus it on the vernacular of how we do it in ChatGPT. But again, it's applicable across product. So first and foremost is custom instructions. So when you think about using generative AI, if you're just in ChatGPT and you just type into the text box, it's using the default instructions, which is just you're an AI assistant here to help provide answers, something like that. And what you can do is you can go into custom instructions. You can give very hyper specific rules for its custom instructions, which helps guide the LLM towards what you're looking for. So for example, let's say I'm in ChatGPT and I need to write some code. I may go into custom instructions and say, hey, you are the world's best coding assistant. You write high quality code. It should be over-indexed on readability, second for performance and optimizations. And you give it those prompts, or you give it those custom instructions, which then help it know what you're looking for. And you don't have to keep rewriting that every time you paste something in the checkbox or in the text box. So that's very powerful, and don't sleep on it. Even though you only have to put in a few sentences, it makes a massive difference in the output when you set custom instructions in ChatGPT. Second is custom GPTs. And so this really, they've encapsulated this concept of RAG, retrieval augmented generation. And I'll take a minute and explain what this is. Retrieval augmented generation is a way that you can provide the LLM specific clues about the data in your database or in your datascape so that it can answer correctly without having to have a full understanding of all the data in your company. And so the way that works is you write a prompt, and that prompt is then used to do an ML-based query where it looks in a set of documents for sections of those documents that are relevant to the specific prompt that you just wrote. It then passes in your prompt along with those chunks, those sections of the documents that are relevant into the LLM for it to then craft a response. And so in ChatGPT, when you think about custom GPTs, the way this works is you say, go in and say new GPT, and you can upload PDFs or just a wall of text about your company's information. And so, for example, and I'm going to talk about a more detailed use case here in a minute, but you can imagine if you uploaded knowledge-based documents, API documents, just rules of the road for your business, you can then have a custom GPT that you can then ask questions of, and it will be feeding in that relevant information so that it's giving you contextually relevant answers that are domain specific to your problem. So really, really powerful. The example I have here is, hey, maybe you have a rules document for doing a legal document analysis. You can make a custom GPT out of that, and then it's going to be able to answer and follow the rules of that document when it provides the answers back. Chain of thought reasoning. And so this is really surprising, but early days of ChatGPT and other LLMs, people found, there's all these benchmarks, MMLU, there's dozens of them that help us compare LLM 1 to LLM 2 to see how they do. And you have to have some way to measure them to see which one's the best, right? Or at least which one's the most performant. But what we found was if you tell the AI, hey, I want you to break this problem down step by step, don't just give me the answer, walk me through your chain of thought to get to the answer. So like if you were to ask an LLM, hey, what's 2 + 2? Early days, it was a crapshoot whether it was going to tell you 4 or not. It might hallucinate. We'll talk about hallucination in a minute. But if you say, hey, break down for me how I get the answer of 2 + 2, and it walks through its thought process, it's much, much, much more likely to give you the correct answer. And it's verifiable by you because you can walk through its chain of thinking to make sure it didn't have a flaw or a fault in its logical path. And so what we found is that by doing chain of thought reasoning with an LLM, which is really just asking it to break down its thought process, produces results with lesser models, can produce results that are better than frontier models when they're asked to do chain of thought reasoning. So don't be afraid to ask the LLM to break it down. Requires a little more work on your part, because then you have to look through what it told you. But it's really the best way to go to make sure you're not getting shortchanged on your answer. Okay, so self-reflection. We had a prior webinar a few weeks ago where I talked about agentic workflow, and one of the techniques is self-reflection. For anybody that's been following the news, actually OpenAI just released a new class of models called O1 and O1 Mini, and these are actually built-in self-reflective models. So when you think of an agentic workflow, where you have a workflow where you're iterating through a problem, you could build self-reflection yourself by saying, do a thing, and then look at the output, and then review the output, and keep it basically asking itself over and over and over. I'll give you an example. One of the things that Constantine's going to show is how we use AI hints in our product to fortify extraction accuracy. And what we actually built a self-reflective agentic workflow that took a set of documents and said, hey, here's the documents and their metadata. I want you to create AI hints that produce excellent extraction results. And what we found was that when we went through a loop 10 times, it produced hints that were actually better than we could produce as humans. And so self-reflection is a very powerful thing. And when I go back to OpenAI, they found this to be so powerful, they released a whole new set of models called O1 that do the self-reflection under the hood. And so I don't know if anybody's messed with it or not, but it can actually think for up to 90 seconds in this iterative loop trying to solve the problem. And I've been blown away by the performance of these models and their ability to reason and think over complex issues. Really, really promising. And so this is a great technique, and it allows you to get maximum value even with lesser models. So highly recommend thinking about self-reflection and how you'd apply that in your work streams. Temperature and token adjustments. So temperature is not exposed in ChatGPT, but I want to make sure we're kind of on the same page with this. So people talk about hallucination. I think hallucination is really just creativity, if you think about it, right? It's just being creative, because the LLM is really trying to give you the answer it thinks that you want, kind of. And so setting temperature allows for you to tell it to indicate how creative do you want to be. So when you're using the API with OpenAI or any of the large language models, you can set temperature from 0 to 1. And so depending on whether you're looking for generative use case, you probably want high temperature because you're wanting it to riff and freestyle and be creative. If you're asking it to extract relevant facts off of a document, you probably don't want it freestyling and making stuff up, right? So you want to give it a temperature of 0 or 0.5, 0.05 or something very, very low. So that's really key. And then max token adjustment, you can tell it how many words you want it to respond with, but adjusting how much latitude you want to give it in its response will adjust the flow that it goes through when it goes through its neural network. So if you really want a terse response, you can trim down how many tokens can come back, or if you want it to be very verbose, you can increase it. Most large language models these days cap the number of response tokens at around 2 to 3 pages of text. And I think that's for an architectural balance perspective. Some allow you to have tens of thousands of response tokens, but generally less is more when you're thinking about max tokens from a response perspective. And then finally, I remember my very first day at school in Computer Science 101. I remember my professor walked in, and the very first lesson that he taught was, if you can't articulate your idea on a whiteboard, don't write it into the compiler, right? That was the message. And I think the same is true for really any domain, right? If you're not really sure what you're wanting to do, don't just dive headfirst into producing the product. And so being strategic about how you build out your prompts will produce amazing results, and it will allow for you to have a systematized approach to solve that problem in a repeatable way in the future. And so what I mean by this is, if you just drop right into the text box in ChatGPT and it's just stream of consciousness, you might have a winner, or your mileage may vary significantly depending on what exactly you put in and how you structure it. So instead, if you think about, hey, I'm going to plan out a set of prompts, and I'm going to ask for this, but I'm going to ask it at a high level because I know where I'm going next, but I don't want to overload the LLM with too much context. And then once it produces the result, then I'll ask for this, and then I'll ask for this, and maybe you end up with a tree structure of how you ask those questions. but building that out can help you produce very repeatable, predictable outputs without a lot of the variability. So be thinking strategically about how do you want to attack the problem with your LLM versus just stream of consciousness. Now, obviously, as LLMs get better, maybe you don't need to have that much strategy going into it, but having a few minutes of prep time before you get into your chat session can make a big difference. Okay, so let's talk about a few real world examples. So consistent and engaging blog content with custom instructions. So Bart, our VP of marketing, reaches out for me to time and said, Brad, I need a blog post series. I need you to write some blog posts on this topic. And I don't know about all of you, but with my day job, I got a lot of ideas rolling around in my head, but maybe not a lot of time to deliver those. Also, I'm maybe not the best at communicating with the same voice, blog post in, blog post out. So I used prompt engineering to really help me stay on plan when it comes to blog posts. So I wanted to maintain a consistent voice and style. I wanted to simplify the approach so that I could do this repeatably for Bart whenever he asked me, right? So what did I do is I made a set of custom instructions that I put into ChatGPT anytime I'm putting my blog post hat on and start writing it. And I'll just read a few examples here of what this looks like. I won't bore you with the full details, but my custom instructions are like this. Title should be provocative and contemplative, sparking immediate interest. Article format should start with an unexpected revelation or lesser known fact. Use subheadings. And subheadings and segment and guide the narrative. Incorporate anecdotes, historical events, or pop culture references. Tone should be conversational, introspective. Engagement techniques use direct questions to invite readers into the narrative. Accessible language, aiming for clarity over complexity. Avoid jargon. Focus on terms and concepts that resonate with a wide audience. Call to action. Engage readers with further suggestions to subscribe, share, or explore more content. Aim for a medium-length articles around 5 to 7 minutes. Right, so you can see, and there's more there, but you can see the point, which is if you build out those custom instructions that help guide the LLM, now you can systematize this and produce results in and out every single time that follow this rubric, and that's really, really powerful. So again, it helped me develop preferred terminology, brand voice, and stylistic preferences, and it really allowed me to shortcut the time. Right, for me personally, I can produce 2 or 3 high quality blog posts in the time it took me to write one traditionally with this approach. And certainly with this approach, we're able to see a massive reduction in content revision time because they're all kind of stylistically the same. It doesn't take us nearly as long to have somebody wordsmith it and make sure that it looks great. So writing blog content is much easier with custom instructions. And that's a great example of how you can just reuse that from blog post to blog post. Okay, so second one is using custom GPT. So I talked about custom GPTs being the retrieval augmented generation technique offered inside of ChatGPT. For anybody that's used ChatGPT, you'll notice that it'll tell you as a cutoff date, right? It goes, oh, my knowledge is cut off at this specific date and time, and it's usually somewhere between 6 to 18 months in the past, right? Even when the models just come out, I guess it takes them long enough to train it that it can't have most up-to-date knowledge. And here at KnowledgeLake, we're moving quick, right? We're publishing new capabilities in our product, new APIs. So oftentimes, ChatGPT doesn't know about the changes we've made to our API. And, frankly, I want to be able to have my services team deliver customizations, leveraging our API, and using an AI copilot to help write that code in a very efficient way. And so what we do is as we release new versions of our product, we deploy a new custom GPT that has all of our specification documents from our API site, from our documentation site, along with concrete usage examples. We drag all that into a single PDF and we upload it into a custom GPT. So it's just taking all the artifacts we've already built over time, building our documentation, creating a PDF and uploading it to ChatGPT. And now we have a custom KnowledgeLake API coding assistant. And so what that means is, as a developer on the services team, I go in and say, hey, I need to write an Azure function that integrates with the KnowledgeLake API. I want to kick off a workflow. I want to set these properties. I want to do this. I want to do that. Go. And then because it knows our specification, it has real world usage examples in that custom GPT. It's able to produce high quality code without the GPT-4o having any knowledge of the KnowledgeLake API, and it's doing that simply through a custom GPT, leveraging documentation we already had. So for us, it produces high quality results. My services team can crank out code about 50% faster with this AI assistant. And all we had to do was take information we already had and expose it in a custom GPT. Really, really easy. No special skills required. It's just drag and drop inside of the ChatGPT interface. And same thing with custom GPTs. One other use case is knowledge base articles. Customers open support tickets. Obviously, if the issue is one that we've seen regularly, our support techs will remember that and know how to help our customer through that. But occasionally we'll have an issue that only pops up once a year, but was hard to solve the first time. So generally what we'll do is we'll write knowledge base articles based on those hard to solve tickets. But the search for those is not always ideal. And so what we found is that if our support reps can find the answers more quickly, we produce and provide better customer support. And so we've taken a lot of those KB articles and built them into custom GPTs just by generating PDFs and uploading them into the custom GPTs. And what that allows to do is that retrieval augmented generative search. We can do a search with a specific stack trace or a specific error message. It's able to go and traverse through all the knowledge base articles and recommend what might be a solution to the problem. And again, it seems really simple, but these little changes, if we were just asking vanilla ChatGPT, it wouldn't know anything about our stack traces or error messages. But using a custom GPT, it does, and it's very, very accessible. It requires no technical skills. So I won't belabor this since we already covered it with the API example. And so now I'm going to hand it over to Constantine to walk through some use cases inside of KnowledgeLake.
Great. Thank you very much, Brad. And, I've heard you talk about this many times, but I feel like every time you talk about it, I take away something new every time. So thank you for that. So to piggyback off of what Brad said, so this is going to be how we take all of those skills that Brad mentioned and apply them in our tool to make sure that our customers have an easier experience and can get more value quicker when they're leveraging our software. So we have an app called Intuitive AI, and this is what we use to let our customers train KnowledgeLake, specifically their tenant of KnowledgeLake, in whatever it is they're trying to use it for. So I have a couple examples here. I have a class for invoices, certificate of good standing, checks, and transcripts. And what I'm able to do is give it some sample documents of simply saying, here you go, here's what invoices look like. But on the right-hand side, this is the part that is really interesting about using the prompts behind the scenes. So the way this works, as opposed to having users go into ChatGPT or other LLMs to build custom prompts, we've kind of outlined the structure behind the scenes to the LLM so that it uses the content type as that top tier of information, right? So we're talking about prompt chaining of saying, here you go, I'm going to pass you along text related to an invoice. Once you have that, I have all of these fields that I want. So go ahead and extract like the invoice date, the invoice due date, the invoice number. Then I have a sub prompt below that saying this is going to be in a text format or a date format. And then the bottom layer is we give you the ability to add additional AI hints, which is that secondary prompt to say, for instance, for the vendor name, what I really want is extract the name of the company that sent the invoice, not the bill to or the ship to, right? Because a lot of times different vendors, they use just logos or the font is weird. It's hard to tell. So I've seen, that it can potentially say, oh, I found the company name. It's likely the correct one because I don't see anything else. And it grabs the bill to or ship to. So telling it not only what I'm looking for, but what to avoid is able to yield more accurate results. But not just, we don't use it just simply for extracting information that's on the document itself. It could also be used for things like calculations, where I'm saying, extract the document or the invoice due date if found on the document itself. If not, calculated based on any terms found. And I give it a brief description of what I mean by terms. And when it finds those examples, how to treat them and apply it, and then what steps to do after the fact if it doesn't find anything at all. And this could also be used for multiple variations of what fields may be called, or once again exceptions of a PO number is never the customer number or the order number, as well as things like table standardization of I want you to read the table information and give me back the information in this particular format, so it becomes more predictable. So this has been really useful in being able to increase the accuracy of extraction. And from everything you saw there, there was no need for me to add any kind of code whatsoever. It's just me having a conversation. And the same way that I would train an employee on how to understand what this document it has, is the same way we have interaction here. So with this particular example, with certificate of good standing, I gave my prompt of, in good standing, question mark. So what is the prompt? A company would be considered in good standing if all fees are paid and there's no outstanding documentation provided. Provide answer as yes or no, right? Because I know that in my particular case, this is going to be a Boolean field in the back, and I want to be able to surface the information a certain way that makes sense for the user that's going to be doing the validation after the fact. So in this particular environment, the answer itself will never physically be on the document. So I'm telling it in the plain English, just here's the parameters needed to make sure that you can make a proper decision. And I won't go into detail about a lot of the stuff, but just kind of want to show you some of the use cases where here's how you could find information. It's in this particular format. Um, you know, I want to output, if it's a text file, the data in a certain format because it may be written out as opposed to written this way. Does the legal amount match the numeric value, right? So I'm giving it a prompt to say, compare these two values and give me an output accordingly. So you have a lot of flexibility in being able to quickly train the model and get the information that you want by simply dropping in these hints of how you want things structured, give it examples of how to handle certain exceptions, and what it is that you're looking for. So what the outcome ends up being is something like this, where I uploaded 5 documents. It recognizes that this is a certificate of good standing, so it does the classification on its own. And then using the prompts that I gave it, it's able to make a decision on, yes, it's in good standing. Here's my course information based on the parameters that I gave it that I was looking for. I have a check here. In this case, does the legal amount match the check amount? Yes, it does. In this case, I just removed that extra value so that the legal amount and the check amount no longer match. So nope, does not match. So I can flag things as exceptions if I wanted to. And for things like invoices, as I mentioned, drop this guy in here. There is no invoice due date on this document, but I was still able to calculate it based on the terms found. And what it looks like on the back in terms of having that reasoning chain is, so this is the back end of what's happening, and it outputs an explanation. So I'll start with the last one because we were just on it with that invoice. So if I read through what I could see, terms mentioned are net 30, which means invoice is due in 30 days. So it outputs a reasoning for me. So as an admin, if I ever have any questions, well, why the heck did it make this particular decision? I could look at its reasoning and then go ahead and maybe fine tune my prompts if needed to say, okay, I could see maybe I gave it incomplete or improper instructions. Here's its reasoning. It came up with this answer, and that's why it did what it did. Likewise with the checks, it breaks down, what it found, $25, $25. And here was written out was just 25, so no, right? So it gives you reasoning all through it to be able to figure out what's going on. Once again, in good standing, the document states that the corporation was filed on October 31st. The document mentions that the corporation has paid all its fees through December 31st, 2025, and status is active. Therefore, based on the parameters that I gave it in my prompt, it made the decision that it is indeed in good standing. So, the important thing to note is, I think as Brad mentioned, yes, there's always a chance that you won't get the correct answer, but by utilizing some of these techniques to be able to provide some reasoning, some chaining of it, and giving it the proper instructions, you're really increasing your odds greatly by being able to get proper information extracted from these documents, or decisions being made so that you're getting the most out of whether it's our tool or any LLM. by leveraging these things together, you're getting a lot more comprehensive results. As you can see here, in these use cases, if I was a user and I'm responsible for validation, I don't have to do any more key from image. All this information gets automatically populated for me and can go on to whatever the next part in the workflow is. So because we took our time in the beginning to give it the proper prompt, the rest of it becomes automated. And as an employee, I can be more effective and do more of my knowledge-based work. So I'm going to pause here from a demo point of view. Brad, if you want to switch back over to your side.
All right. Thanks, Constantine. Great stuff. So we'll go to a Q&A here in just a second, but I just wanted to let everybody know we do have 5 spots available for a no-charge proof of concept to help you with your AI journey. You can use the QR code here to complete the POC form, or you can email Pam, pamela.benke@knowledgelake.com. We'd love to interact with you and see how we can help you out on your AI journey. So feel free to reach out, and we'd love to continue the conversation. So going backwards here, we do have some time here for Q&A. So let me take a look here at the questions and see what we got.
Yeah, so for the audience, please put your questions in. There's a Q&A section at the bottom of your screen, I believe. Just go ahead and fill those in, and then I'm going to take a look and see what we've got coming in here.
Looks like I can go ahead and kick one off here. Looks like we got a good one. So how do you ensure the security and privacy of client data when using ChatGPT or inside of KnowledgeLake's solution? So great question, and I guess I'll answer it in 2 ways. If you're thinking about it from a ChatGPT perspective, Plus users and Enterprise Plan users have the ability to check a box that says, hey, I don't want any of my prompt data to be used for training or retraining, and that they give you an assurance that it's sandboxed and isolated and it's not being used to further train their system. If you're not on Plus or you're not using Enterprise, you don't get that assurance from OpenAI. For KnowledgeLake, we leverage everything we offer inside of the KnowledgeLake SaaS platform runs inside of Microsoft Azure, and so we only use the Microsoft deployed versions of our AI models, which have very, very strict DPA agreements that cover none of the data can get used for retraining. None of the data is provided to OpenAI. It's all sandboxed and isolated. So for us, we have our DPA with Microsoft, and that gives us very, very tight assurances around data privacy and being safeguarded. If you're using ChatGPT, obviously you want to work with them, but Enterprise and Plus users do have checkboxes to make sure their data is not being used to further train future models. Let's see. Okay, I got another one here. How does temperature and max token adjustment affect AI hints inside of KnowledgeLake for IDP use cases? So obviously what you saw Constantine show, it's really, really important that we get the answer right and that there's not hallucination, right? For the majority of these type of answers. So we traditionally set the temperature down to 0 for IDP extraction style use cases. Obviously, there are other scenarios like content summarization or asking it to have an opinion. If you're doing those sort of things, you may want to dial the temperature up a little bit. But for vanilla IDP use cases, generally we have a 0 temperature setting as our default. And then when we talk about max token adjustments, some of these documents can get pretty large, right? And so we generally want to have as many tokens as possible for the response. So when you think about the current models, the smallest token context window is normally 128,000 now, up from just a few thousand a couple of years ago. And so we'll generally reserve the full 8,000 tokens for the response, which allows for the AI to provide a pretty robust answer. So you can adjust that, but generally when you're getting facts off of documents, especially tables like you saw Constantine show, you need to make sure you got ample context window for that response.
Awesome. And just a reminder, if you have any other questions, please put them in the Q&A section. And the POC, just look at your attachment section. The link is there to the form to be considered for a free POC, or scan the QR code, or you can email me directly. I don't see any other questions at the moment. I think we all learned a lot from this webinar. So I really want to thank you both, Brad and Constantine, for a great webinar. To the audience, please join us tomorrow. We have another webinar scheduled where we'll be discussing KnowledgeLake and intuitive AI for county level workforce efficiency. So please join us for that tomorrow. And thank you for tuning in. Really appreciate it. Guys, thank you so much. Actually, I think I see a question pop in.
Yeah, let's give it a go. So how does the size of the document impact latency of the model? It's a great question. So obviously, the larger your context window, the more that the LLM has to chew on the information. I'll say really two things. One, for KnowledgeLake, our system runs in a background process. So we have horizontal scalability. So documents come in, it runs through our IDP use case, and then it's presented to the user, and there's no latency because it happened in a background process. Also, what we found is that the emerging models like 4.0 mini and 4.0 have significantly faster time to an answer. So the latency is much lower and the throughput is much, much higher. And so what you're seeing with OpenAI and other generative AI companies is they're really trying to focus on reducing latency and increasing speed. So, if you have a 1-page document, answer could be a second or two. And if it's a 100-page document, yeah, it might take a few more seconds. But again, because that's happening on a background unattended process, and then the answers are presented to the user, there's no wait, there's no latency. So great question, and happy to dive in more on that with you. If you want to reach out, I'm happy to talk about that in more length.
Awesome. So again, reach out to us for the POC. Join us tomorrow for another webinar. And thank you all so much for your time. Enjoy the rest of your day.
Thanks,
Take
everybody.
care. Bye-bye.